Hello guys, so in the last video we left off at uh, after completing all this stuff and decided to start 10 minutes to pandas in this video. So like last time, this time also I haven't read it at all, but I've done some preparation. So I just went through the topics which are going to be covered, and one of them was reading all CSV files and all of that. So I had seen a tutorial by Corey Schaffer, if I'm not pronouncing that wrong. So I'm using the same data which he did, and that is the Stack Overflow survey data. So basically, you can just Google search Stack Overflow survey data. You can click here, and you can click on download the full data CSV set. This page would load up. Then you can just download it. I've already downloaded it right now, so I'm not going to download it again. Here is the data. Another thing which I'm going to do is just go here and create a new folder called data, so it would be easier to access, and place this in there and uh, extract all the files. So yeah, we have all the files right here. Now let's get started with 10 minutes to pandas. We'll use all that stuff as and when needed. So this is a short introduction to pandas, geared mainly for the new users. You can see more complex recipes in the cookbook. I don't know what that is as well, but let's see. We'll look at it in some other video. Primarily, we import these two things: import numpy as np, import pandas as pd. Okay, so np and pd are basically aliases. So when you use pandas functions, you'll have to use pd or pandas. If you import it as pd, then you can use pd. Otherwise, if you just import pandas, you have to use pandas. So typing pandas every time would be cubism. So they have used pd. Like you can see here, they are using this pd here. Otherwise, if they hadn't imported it like this, they'll have to use pandas here. So let's just follow along as they do stuff. So I have a Jupyter notebook open right here, and I'm going to do the same stuff as they've done already. Import numpy as np, import pandas pd, and that's done. So I thought this would be a good way to follow along. I do this when I watch YouTube tutorials mainly. I follow along, I pause the videos, I write the code myself, and then I run it. So let's just look at object creation right now. Object creation. Creating a series by passing a list of values, letting pandas create a default integer index. So let's look at what that means with this example. So they've taken this s and they've created a series pt.series, and they've inputted this list, and there are all these values in the list, and when they output s, they get this indexed sort of list type with the data type float 64 because it saves them as 64-bit entities. So I'll explain it once in the Jupyter notebook as well. So I copy it, and here it is. I run it, and then I just print out s. So basically one thing which might pop up is np.nan. So here np is this np numpy and nan is none. So basically np.nan is a way to represent none. Series are basically these sort of rows in pandas. So you can sorry, columns. So basically this is a series. This 1 3 5 nan 6 8 is a series, and this is the index for that series, right? So I guess, and the data type is float 64. I think you can do the data type here. I'm not sure. um, yeah, so d type, and so let's look at how to add d type in pandas. Pandas 32-bit date type. So basically, the best way to do this stuff is just to look at uh, the Stack Overflow or other websites when you can't figure out something. So, okay, as data type is used. I was thinking something along this line only. And instead of doing this, we can just do this as data type np.float32. This should work. So now these are stored as 32-bit floats. You can, I guess, do 16-bit floats, and now they are 16-bit floats. So just a way of showing. And now let's go back here. Okay, we were here. Creating a data frame by passing a numpy array with a date time index and labeled column. So now we're going to create a data frame and using a numpy array, and the index would be date time based and the columns would be labeled. So like they've used dates is equal to pd.date range 2013-0101 period 6. So what this does is you get like 2013-0101, 2013, the 2nd of 1st of Feb, the 1st of March, and so on. And 0, yeah. So what they're doing is they're creating this index and then they're using this index right here. So I'm not sure if this is the day or this is the day. So because the format which I am familiar with uses day, month, and year, but I don't know what's the default format in Pandas. So let's just look that up. Default date format in Pandas. Year, month, date. Okay, so that would be so the I was wrong initially. This is the 1st of January, this is the 2nd of January, 3rd of January, and so on. And what they've done is they basically used this to create a date time index, and then let's do this step by step. So I'm going to copy this part in of code here and then printed dates like this. So let's see if what happens if we do say periods of 100. So you can see they've made periods of 100 right here. Okay, so let's keep it at 6 only. And now let's go back here. So this is the operation which is used to create a data frame, pd.dataframe. And now you have to input the values which you are going to use. So what they've done is chosen random values, and they've set the index to be this dates uh, pandas date range, and they've named the columns from this list. So you can see there are 6 rows and 4 column full of random stuff, and the column names are going to be taken from this ABCD list. So let's copy it. Um, and now let's run it. So you can see this comes out as a comes out as in this beautifully formatted way. So let's now look at what happens if you say assign a E here. So you can see as there were no more columns, so this doesn't make any sense to have 5 column names. So there could be nothing it could do. Now, however, if we change this to 5, this works just as well. np.random.randn gives you random numbers. Uh, so you can have a look at them here. Dot rand n. So this is just the same, it returns a list of random numbers. So one thing which I would encourage is you should always look up the function which you're not familiar with. So for instance, right here I was not familiar with this rand n. I was familiar with the rand function, and in the rand function, the thing is you get only numbers from 0 to 1. So like if you run it here, you can see all the numbers are from 0 to 1. But if you use rand n, you can see there are numbers in negative also, negative 2 as well, numbers greater than 1 as well. So that's why I decided to look up rand n. So basically it returns sample from the standard normal distribution. You might now wonder what is the standard normal distribution. So just look that up as well. Standard normal distribution is this curve right here. This basically never tends to 0, but then it basically gives numbers which lie under this curve. So that's what I could interpret from that stuff. However, if I make a mistake, you can just comment it and I'll look it up, fix my error, and yeah, that's it. So now let's look at creating a data frame by passing a dict of objects that can be converted to series lines. So now the first thing which might pop up to you if you aren't familiar with dictionaries in pandas is what is dict. Dict is basically a data type in Python, which is dictionary. Dictionary are basically characterized by this unique thing that they have keywords and the assigned values with them. So A is the keyword, A is the key basically, and 1 is the value to the key, B has this, C has this, and so on. So basically, if you try to make a data frame out of a dictionary, what it does is that all the keys are converted to the column headers, and all the values in them are converted to the values inside the 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 rows beneath the particular column name. So basically, like if you see here, A is 1, so A is 1. The timestamp is 2013 0102. So it's like this here. C is a panda series from 1 index list range 4 and np.array 3 into 4. So basically it's creating an array of 4 numbers where 3 is, so they're basically trying to input in a list, and the list is just 3 4 times. So basically if you do this operation in Python, what is going to happen is just this: you're going to get a list of 3 4 times, and then they're using this categorical where you're using this list, and in the end they have just this food thing, and f is all these foods. So basically let's just play around with this a bit. So you have this df2 here. So now let's see what happens if let's say if it was just 3. You can see nothing is going to happen because it's going to give an error because arrays must all be of the same length. So let's turn that back to 4. However, let's say if we convert all this stuff into 5, and let's say we add another column here and call that test once again. So you can see it ran. So you might wonder why aren't we doing anything with this 1 point and this PD data stamp. So basically what you can clearly interpret from this situation is that if you are using a list or an array or a series or a categorical data set as your column, then the number of entities in that set should exactly match the number of columns. However, let's like here you have assigned 1 to be just 1. So it's going to keep every single uh, row where the value in the row in a column to be 1 because there's nothing else mentioned by you here. However, if you have entered this as a list as well, say something like this, so now you will get an error because now you're trying to do a list to which is not going to work as expected. So now you see you have to match the exact length of the array list. So you might be wondering why I'm teaching this stuff if I don't know all this stuff already. I'm looking it up. So basically, the intent is I'm going to learn new stuff myself. I've never read the documentation before, and in the same time, I'm going to maybe help some of you guys out as well. If you feel this is not worth your time, which I totally understand, it can be not worth your time because you're basically not learning much in this amount of time. The content density is less. I'll recommend highly recommend watching other lectures. I'll have some in the description, and you can look them up as well. So yeah, you can look at the types as well. So if you do this df2.types, did I do something wrong? Yeah, d types, data types. So you can see this is a float 64. These all are floats. This is a date time. This is float 32. This is a int 32 bit. This is a category, and this is an object. So yeah, simple stuff. If you're using IPython tab completion for column names, it's automatically enabled. Here's a subset of the attributes that will be completed. df2.a as you can see, the columns A, B, C, D are automatically tab completed. EF are there as well. The rest of attributes have been truncated for brevity. I'm not familiar with what this is, so let's just look it up. Okay, so IPython is another, seems like something like Jupyter. Yeah, so I'm using Jupyter. IPython is another alternative to that. As no, to get started with IPython, the Jupyter notebook. Okay, so it's uh, some sort of add-on for Jupyter. I'm not going to deal with this stuff right now. Let's move ahead. So viewing data. This is how to view the top and bottom rows. Yeah. So basically, if you do something like this, df.head, what basically happens is you get the first 5 rows, and if you do df.tail, you get the last 5 rows. So in our case, df.head, df.tails do not vary too much. There's just this one line. There are six rows, so there's one row which gets changed. But if you have a very large data set, you can get a general idea of what sort of data it is by looking at the top or the end of the data. So now displaying the index, yeah. So you can just look at the index of the data as well. Just type df.index, and you can get the index, the data type, and the frequency. The frequency is D here. Frequency D, as far as I can understand, refers to the frequency at which the dates are changing. So they are changing by one every interval. We Yeah, that's what it is. And you can also look at the columns, doing df.columns. So now data frame dot to numpy gives a numpy representation of the underlying data. Note this can be an expensive operation when a data type has columns with different data types. Data frame has columns with different data types, which comes down to a fundamental difference between pandas and numpy. Numpy arrays have one data type for the entire array, while pandas data frames can have one data type per column. When you call data frame to NumPy, pandas will find a NumPy D type that can hold all of the types in the data frame. This may end up being object which requires caching every value to a Python object. So basically what this means is if you use this operation data frame to NumPy, it converts the entire data set to a NumPy array. Now the good thing about pandas is why people use pandas is you can see here the data types in each column are different. They can be different, they can be same depending on what sort of data you have. But the thing with NumPy arrays is in the NumPy array, every single thing has to be of the same type. So if there is one float, then everything has to be a float. If there is one object, then everything else has to be an object, and so on. So this is why people choose pandas over uh, NumPy for such a data analysis stuff, because you never know what the type you're getting your data So I had just clicked on the data frame to NumPy, and you can see you can have this data frame to NumPy operation right here. It converts the data frame to a NumPy array. So let's have a look at huh. So for RDF, our data frame will convert is yeah. So basically, let's convert df dot to underscore NumPy if I'm not wrong. Yeah, so it's converted it entirely into a NumPy array. So the index has been removed. So there were one, two, three, four, five columns. I reckon one, two, three, four, five. Yeah. So 1.075 minus 0.7. Yeah, yeah. So this is each uh, row has become now is now being printed like this. So basically, you can think that the columns are going from top to bottom. So now let's go ahead. Yeah, so you can convert df2 to numpy as well, and it gives the data type to be objects. You can look at the type here as well. You can see all the data is float 64. So it takes the type which can represent most of the stuff. Here all the entities are of different types, so it took the data type to be object. uh, Relatively expensive, yeah. Okay. Yes, here's the point, does not include the index or column labels in the output. So now let's go ahead. Yeah, df.describe, it's a very important function in data analysis. So what it basically does is it gives you a brief idea of your columns. So A, B, C, D, E are the different columns. It gives you the count, the number of objects in each column, the mean of the mean of the data, the standard deviation, the minimum value, where there's the 25% value lie, the 50% value lie, the 75% value lie, and the maximum value in each column. So for instance, you can use the 75% and the 25% to find the inter quartile range, I believe. Quartile range. Yeah. So the third quarter minus the first quarter. So now let's go ahead. Transposing your data. So basically, if you're familiar with some linear algebra, uh, what's wrong? Okay, you might have used the transpose function in matrices. What it basically does is converts the rows to the columns and the columns to the rows. So if you transpose it twice, it again becomes the same thing. You can sort by axis and sort by values. So what sort by axis does is you have your original data right here. So I just print df right here, and now I'll sort by axis. So I'll use just this thing. Yeah. So now you're seeing axis 1 and ascending is equal to false. So ascending is equal to false basically means descending. So the highest value should be on the top, right? And you can see axis 1. Um, Wait a second. The axis 1 in this case is going to be uh, sorting along axis 1. And so whenever I get stuck, I just uh, look this up, something like this. Refers to the columns while 0 refers to the rows. Yeah. So it's sorting along the columns in case you are sorting by columns, especially index 1, which is column 2. Indexing in Python starts at 0. Okay. So column 2 is right here. Um, uh, uh, this column is entirely same, and in this column has been changed. This column has been changed as well. Uh, yeah. So basically, it's sorting along the columns. If we have a look at this example right here, so basically the columns themselves were sorted. If I'm not wrong, so 219874 is the largest column numerically. So it is the first column now. Uh, Similarly, in our data set, yeah, there is 1.07. Let's just try to spot this value. Where did it go? 1.075. 1.075. Yeah, here. So this entire column is now here. This column is here. This column stays where it was. This column went here and this column went here. So basically the data was sorted in such a fashion that the entire columns are now sorted in the descending fashion. Right. Uh, let's try to do this sort as well. If now you're going to sort in according to B, so um, basically the values of column B have been sorted. So minus 0.7 is the smallest, 0.1, then 0.5, 0.6, 0.72, and in accordance to this the rows have been sorted. So this entire row might have been here, it has come down and so on. So if you are going to sort with C, you're going to get this result and so on. So rather than using axis equal to 1, I think you can use axis equal to column if I'm not wrong. Um, Columns, yeah, columns. So now if you just transpose this to rows, you can sort it by rows as well. I guess this video is getting quite long and we've barely scratched the surface. So let's stop right here and we continue from this selection part in the next video.